Hello everyone, you are welcome to the GMAETS 41's channel. In this video I have this interesting question I am going to solve for you. If you're new to this channel, please do subscribe and turn on the notification bell so that once I upload any new content, you will be notified. And if you are returning and yet to subscribe, kindly subscribe and follow us as we release wonderful educational tips. The question I have on the board here is a differentiation problem. I have the function y to be equal to x squared times sine inverse of x over 2. And I'm asked to obtain dy dx. Okay, so we have y to be equal to x squared sine inverse of x over 2. And then I am asked to obtain what? Dy dx. First of all, I want you to observe this question and see clearly that the function is a product of two terms. Two different functions are being multiplied there. One of them is x squared. This x squared is a polynomial function. And then it's multiplying this sine inverse of x over 2. Sine inverse of this function is a secular inverse function. Is that okay? We have sine inverse, cos inverse, tan inverse, and the other ones. Now, how do you handle this differentiation? Again, I want you to observe, like I said, that this is a product of two functions. Therefore, we need the technique of differentiation, which we call product rule. And what does product rule state? That if you're given y to be equal to u times v, and then you have to obtain dy dx. U and v are functions of x, okay? How do you go about differentiating it? Now the formula states that dy dx is equal to keep u constant, differentiate v with respect to x. So you have u dv dx. Then plus keep v constant, differentiate u with respect to x. So you now have plus v du dx. That is the formula. That is what we refer to as the product rule. Is that okay? Now, the clear interpretation of product rule is this. You are given these two things, alright, and they are being multiplied. And then you are asked to obtain the derivative of the function. So, product rule said, keep this constant times differentiate this blue marker with respect to, okay, let's say with respect to x. So, simply keep this black constant times differentiate this blue, plus you will reverse the process. This time around, keep this blue constant and differentiate what? The black. Is that okay? That is what product rule is all about. And so we can apply that here. There is no need of stressing ourselves, saying let u be equal to this, let v be that. We don't need that, except to decide to solve the problem using full chain rule. But you remember that I have always talked about the major-minor differentiation. And with that, of course, you can be able to handle any differentiation as fast as possible. Before I move on into solving this problem, I want to show you something about sine inverse. If you're given sine inverse of a function, are you following, right? I always like approaching differentiation using this term, f of x over a. Somebody gives you y to be equal to this and say you should find dy dx. Okay? Dy dx. You know, normally when we are dealing with standard derivatives, most times what we see is y equal to sine inverse of x. Is that okay? This thing cannot solve a question like this, except you have to rely on chain rule saying let u be equal to something. But with this standard, you can avoid the issue of using full chain rule to solve the problem. And so I want to show you the standard derivative of sine inverse of f of x divided by a. Dy dx there is equal to, you differentiate this f of x. Are you there, right? Differentiate the f of x. So we're going to have differentiate with respect to x, that function f of x, alright? Then multiplied by, you now differentiate sine inverse. The derivative of sine inverse is 1 over square root of something. And what is that? Let's see. So times 1 over square root of of what? Watch as I pick them from this term, okay? It's going to be square root of, you see this denominator, this a is a constant, is a number. So it's going to be square root of a, then minus, you come to this term, that is the f of x there. So you're going to have minus f of x all raised to power 2. That is square. That is the standard. If you're to work with this standard, what you will get is that dy dx is equal to, in this case, you just go straight. And they tell you that the dy dx of this sine inverse of x is simply 1 over square root of 1 minus x squared. Okay, there are a lot of information that this standard does not give us. Okay, for example, this standard does not tell us where this one came from. That is why this is the best thing you can use in learning differentiation, yeah, and you will start enjoying differentiation. From GMAETS 41 here, we make the concept of calculus very interesting, fun to learn. You can join our Telegram channel for full range of learning of these concepts. See, you see this standard that is used most times? This standard doesn't tell us that this 1 came from x over 1. Are you following, right? And this standard somehow does not show us that this 1 is being squared. Of course, it was not necessary to square it here because 1 square will still give you what? 1. So there are a lot of information that this standard does not expose. And so I think you can work with what I've shown you here. So this is the standard derivative of sine inverse. Coming here to solve this question using product rule. Remember, I will keep x squared constant, differentiate this whole term, then plus, I'll now keep this whole term constant and differentiate x squared. So let's go. Directly, dy dx is equal to, I'm keeping x squared constant, then I'll differentiate this sine inverse of x over 2. Now if you compare this with what I showed you here, our f of x is this numerator function of x. Then our a is this denominator 2. And with that, you'll be enjoying the process. Okay? So let us go. I'm going to multiply this by the derivative of that sine inverse. Remember first to differentiate this f of x. If you differentiate x, you're going to get 1. That is the meaning of this f of x dx. Then multiplied by differentiate sine inverse. And the derivative of sine inverse, like I said, is 1 over square root of something. Square root of what? The denominator number here, are you following, which is 2. So it's going to be 2 squared minus, you come over to this, which is your f of x, you write it out and then you square it. Good, I've differentiated that sine inverse of x over 2. Next, we are going to reverse the process. This time around, I will keep the sine inverse constant. So sine inverse of x over 2, I'll keep it constant. And then I am going to differentiate x squared. If you differentiate x squared, you're going to get 2x. And my problem is as good as solved. All I need to do now is just normal simplification. Is that okay? dy dx will now be equal to, this term is x squared, because if you multiply 1 by this 1, you still get 1, times this x squared will now give you x squared in the numerator, divided by square root of, this is 2 squared minus x squared. I can choose to work it out, since this is just a number, 2 squared will give us 4 minus square of x. Coming to this term, I'm going to get plus sine inverse of x over 2 times 2x will give you 2x times sine inverse of x over 2. Take note, you can't split this over 2 from this numerator x, okay? And looking at this, this is my answer. dy dx is equal to this. This is my answer. If I want to do any further simplification, like saying there is something that is common to this term, and that thing is also common here, so I can factorize it out, From what I am saying, I could still say that dy dx is equal to, looking at this, you notice that x is common to both terms. This is x squared, this is x. You can pull out one of the x. Are you following, right? If you pull out one of the x, this will be left with x. Because this x you brought out, if you use it to divide this term, it's going to cancel one x from here, so that this will now become x over square root of 4 minus x squared, then plus this x you pulled out. Remember, it was common here, that's why you also pulled it out. Use this x to divide this term. This x here will cancel this x. You'll be left with 2 sine inverse of x over 2. Okay, so this is another alternative answer to this problem. So either this or this. If it is an objective case, the option will tell you which one to go for. Did you enjoy this? Very fast. I never let you to be equal to anything. Straight on, you get your answer. Alright, remember that we are going to deal with chain rule fully. But for now, I just want you to understand that the concept of differentiation is simple. Very, very simple. Using chain rule to solve problems like this could just make the process a bit complex if you don't have a total knowledge of differentiation. But by the major minor differentiation concepts, you solve it in just few steps and then you smile away. I hope you enjoyed this, right? No much stress. Remember, keep this constant, differentiate this. Plus, keep this constant, differentiate this. I apply product rule here because this is x squared times sine inverse of x over 2. A product of two functions. So you use product rule. And very important, standard derivative of sine inverse of a function. Did I say sine inverse of x? If you learn by saying sine inverse of x, it reduces your knowledge by 70%. Because like I stated earlier, there are a lot of information that this does not give us. That is why sometimes a student may see a problem like this and solving it will be very difficult. Because maybe that student may have learned standard derivative of secular inverse function for sine inverse with this standard. This is the best format. You can learn standard derivative of functions. In our Telegram channel for full range of learning, we have all this concept well explained. You can contact us to join us. Meanwhile, below this video lesson, you have the link to our public Telegram channel. Click on it in order to learn how to join our main learning classes. I hope to see you next time. Remember to share our videos, comment on it, invite learned colleagues like you to visit the channel, subscribe to it because we have wonderful knowledge from the GMAETS 41.